Let's look at question number 4. The diagram shows a sector with center O and the radius of 2.75 centimeter. So the radius is here and the value is 2.75 centimeter. And then the arc length is given as 4.62 centimeter. And we know that theta, r and s is connected by this formula s equals to theta r. So by substituting the values of s, theta and r, you can find the value of theta. So s is actually 4.62 equals to theta times with r, which is 2.75, and theta is equals to 4.62 divided by 2.75, and the answer is 1.68 radian. But if you read the question carefully, you are required to give the answer in degrees. So how to convert the angle in radian to degrees? Yes, it's actually not that complicated. You just need to multiply this value with 180 degrees over 3.142. And the final answer is 96.24. Okay. So always remember, when you give the angle in degrees, write the answer correct to 2 decimal places. Let's move to section B. The perimeter in centimeter of the shaded segment. So what is actually segment? So this is actually segment. And how to find the perimeter of this segment? You have to take the arc length PQ, and then you have to calculate the length of the straight line PQ, and then you have to sum up, okay, these two values in order to get the perimeter of the shaded segment. You already have the arc length PQ, so you only need to find what is the length of line PQ. So let's see how to find the length of line PQ. So there are 3 different methods you can use to find this value of PQ. Okay, I'm just going to show you the 2 methods, which is relatively easier compared to the first method. PQ square is actually equals to 2.75 square plus with 2.75 square minus 2 times 2.75 times with 2.75 cos the angle that's subtended by these 2 lines, which is PO and PQ, and that angle is actually theta, and the value of the theta is 96.24. Okay, let me explain how actually we get this. So this calculation is actually related with what you already learned in solution of triangles. If you are given a triangle like this with the vertices A, B and C, and we can label this side as A, small a, and the length of line AC can be represented by letter B, and the length of line AB, okay, can be represented with the small letter C, and the angle at A is given by A itself. In order to find the length of A, you can use the formula A square equals to B square plus C square minus 2 times BC cos angle A. This is angle A. So similarly here, to find the length of PQ, okay, just imagine this is actually A. So the angle which is opposite to side A is actually theta. Okay, in fact, if you refer to this diagram, the angle which is opposite to the side A is actually angle A. and you can assume PO as B and OQ as C. Basically, this is A square equals to B square plus C square minus 2 times you have B and you have C and then cos angle theta. Now let's find what is PQ. In order to find the length of PQ, you can key in the whole thing on the right hand side straight into your calculator. 2.75 square, okay, plus 2.75 square minus 2 times 2.75 times with 2.75 cos. Make sure the mode of the calculator is in degree. Okay, if you look at the display, it's stated D. Okay, so the angle must be in degrees. Okay, 96.24. Close the bracket and you press equals to. This is the value for PQ square. But what we are interested is with the value of PQ. I'm going to square root this value. And what I get is 4.095. So I round off the value. So I get PQ is equals to 4.095 centimeters. This is the first method. Next, in order to find the length of PQ, we also can use another method. So to find the length of this line here, provided the angle here is theta, this is radius and this is also radius. I'm going to label this as AB. So AB is basically equals to 2r sine theta over 2. So in this case, PQ is equals to 2 times r. R is actually 2.75 times with sine theta. Theta is 96.24. So we take 96.24 degrees and divide it with 2. So relatively, if you look at the formula, is much more simpler and easier to do the calculation. So 2 times with 2.75 sine 96.24 divided by 2. Let me close the bracket and press equals to. You see, we get the same answer. Finally, to find the value of the perimeter of the shaded segment, you just need to take the length of PQ, which is 4.095, and then add it with 4.62. So 8.715 centimeter. Okay, let's move to the next question. The diagram shows a sector with center O. Find the perimeter in centimeter of the shaded segment. So this question is quite similar to the previous one. I'm going to use a simplified version of the calculation. Length arc SAB, which is equals to 38 times 3.142 divided by under 80. So we convert the angle in degrees to radian and then multiply it with 10 to find the length of the straight line AB. We can use the formula 2r sine theta over 2. So 2 times 10 sine 38 divided by 2. Okay, you can write 19 or you can just write 38 divided by 2. It's up to you. Let's do the calculation. $6.633 6.511. Okay, so let's sum up these two values. So perimeter is equals to 6.633 plus with 6.511. Okay, as I already explained to you earlier. So once you already write okay, any values. In later calculation you must key in the values once again. Final answer is actually 13.144 centimeter.